Good morning, evening, and everything in between, my friends. Yesterday, I was taking a look at the channel of Dazzathecameraman, who, if you are not familiar with his work, has quite a nice channel filled with all kinds of interesting videos about the moon, the flat earth debunking, and debunking of other pseudo-scientific nonsense, including the Nibiru worshippers, among others. He's down in Tauranga, New Zealand, and I probably destroyed that pronunciation, but I dare you to spell Tooele correctly. And he did a video called Flat Earth Synchronized Moon Viewing Analysis, and that inspired both of us to try an impromptu session last night, taking photos of the moon at the same time, with the same camera, at the same zoom. And we're both using level tripods, and we time-stamped both images to make sure that we were getting them at the same instant. We took photos at 5:30, 6:30, and 7 o'clock UTC on September 23rd, and we got some interesting results out of it. Let's see, show you first. We'll look at the rotation here. And you can see the difference between Dazza's photo taken in Tauranga and compared to mine in the orientation of the moon. And that's an effect due to the difference in latitudes and longitudes of our two locations that you can see at the bottom down there. And I thought I would verify that in Stellarium. So this is my location in Salt Lake City, and you can see that the moon there looks pretty close to the same as mine that I took at 6 o'clock UTC. If we switch back to Stellarium there, we'll just alternate between my photo and Stellarium. You can see that they're almost identical. So Stellarium is showing the orientation of the moon correctly. Another fun thing to note on the moon, as I took the series from 5:30 to 7 o'clock, is that you can see the moon's apparent rotation through the sky. I'm sure if you've watched it when it first rises, in the northern hemisphere at least, the face of the moon appears to be straight up and down. And then as the night progresses and the moon heads towards setting, the face tilts further and further in a clockwise direction from the northern hemisphere. And you can see this over just an hour and a half. I've marked the angles outwards from some prominent craters and features, and you can see as the time progresses, the moon does indeed rotate to the right over just an hour and a half. And this was taken right as the moon was transiting in the south. It was just about full, so it came to 180 degrees azimuth, almost due south, while we were recording these or photographing these. So that was a fun little observation. And we'll go back to Stellarium here. And Dazza, as you'll note, is pointed with the crater Tycho there is on the lower left of my image, but it's to the right in his. So let's go back to Stellarium here and change the location from Salt Lake City to Tauranga. Oh, oops, wrong place. Tauranga, New Zealand. At the time, the moon had just risen for Dazza, and you can see that the orientation there, put this over on the side, matches his view right there. So Stellarium is correctly showing the orientation of the moon in both locations. And if we adjust stellarium's locations one degree at a time, we'll change it from his latitude northwards up to mine. Watch the moon's orientation. Whoops. Come on, baby. Maybe I have to lock it in the center. If we move northwards to my latitude, about 40 degrees north, that's close enough. And we'll move from eastwards to my longitude at 112 ish. Now we'll come back. You'll see that the moon is in the correct orientation for my longitude and latitude. So there you go. There is another fun effect that I noticed we can see, and that is the fact that because it's midnight, or was midnight at my location, and Daz's was just coming into evening, I am technically about the radius of the Earth closer to the moon than Dazza is, because Dazza is viewing it from sort of a tangential location, and I'm looking at it straight on after midnight, or at midnight. And here's an image of what I'm talking about in Google Earth. Now from the pole, looking down at the top of the world, the sun is coming from the left and illuminating the daylight half of the Earth. I'm in the dark half of the Earth, right here in Salt Lake. The moon, being almost full, is off to the right. Now I have rotated around almost the full radius of the Earth closer to the moon, which would be off in this distance, than Dazza has, where it's just beginning to become dusk. So Dazza would have nearly the full radius of the Earth distance different than I do up here. And we could see this, or I could see it when I lined up the photos in Photoshop. Bring this over here. This was the moon from my location, and I rotated it and stood it upright to match the image I got from Dazza, and I rotated his accordingly at the same amount to overlap them. His is in red, mine is in blue, and when we overlay them, we can see that indeed my disk of the moon is slightly larger than Dazza's. Lining it up as best as I could everywhere else. So, is that the correct amount larger though? Well, I measured the distance from the bottom here to the top, and the amount extra I have up there is about 0.6%. And here in Stellarium, we can get the distance. Where is it? Distance from my location is 396,117 kilometers, more or less. And from Daz's location in Tauranga, the distance is 397,978 kilometers, which works out to about 0.4% or so. So within the margin of my ability to measure accurately and overlay the points accurately, yes, we could indeed see that there was a slight difference in the size of the moon's disk due to our different distances to the moon, which I thought was pretty cool. And there was one other feature that we could see. I lined these slightly differently. because we're looking at the moon from quite different longitudes and quite a fair distance apart, almost 7,000 miles apart, there is a tiny bit of parallax shift at the edges of the moon, so that no matter which crater you try to line up, in this case I've tried to line these up here in the center, and no matter which ones you try to line up, you're always going to have somewhere, like over here on the left, which doesn't. So let's say I try to move and line up this crater right here, this guy. Now when we zoom out, you can see how blurred this side of the disk is. And that's the difference in parallax from our two different locations, or demonstrates the parallax. No matter what craters I try to line up, if I line up Tycho on the bottom, then the ones on the left are out of position. If I line up the ones on the left, then the ones on the right are way out of position. If I line up, I believe that one's Plato, right there in the top, then you can see others on the bottom are out of position, which is another indication that my picture of the moon is not only a slightly different size than Daz's, but we are getting some parallax shift from our different locations. And the total lunar parallax is typically about 1 degree from the widest possible spots on Earth. If I was on the far left edge, well, I say left. If I was on the far eastern edge where the moon was just setting, and Dazza was on the far right where the moon was just rising, the total parallax is about 1 degree, I believe. But that small shift there shows you the difference that it makes over just 7,000 miles. So anyway, that was all we got accomplished. I thought it was kind of a fun observation, and you can do a lot of this yourself in just a single evening. Just take pictures at moonrise when the moon was at the zenith and at moon set, and you should be able to detect this difference in the diameters, at least. You should see the same distance, because at midnight you will be 1 full Earth's radius closer to the moon than you are at moonrise and moonset. So there's another flat Earth fail. Not only is the moon actually not bigger at rising because of the horizon effect, but I guess you could say the moon actually is a tiny bit smaller when it rises. Thank you very much, and I hope to do some more of these with Dazza at some point. And like I say, give this a try. Have a good evening, everybody.